Hello everyone. Myself Ganesh Namjadu. Today we are presenting the research article summary and presentation. My partner name is Sushant Patil. The title of the research article is spam email, an efficient framework for detecting the spam emails using the machine learning. The author is McFork and the team, and the year of the publication is 2025. Introduction. The email spam has become a significant cybersecurity threat, leading to issues such as phishing attacks and malware infection, and for fraudulent activities. The traditional rule-based spam detection methods struggle to keep up with evolving spam techniques. This study process a machine learning based spam email detection system that applies the multiple algorithms to determine the best performance model for accurately classifying the emails as a spam, unwanted, or a harm legitimate emails. Research questions or problems. The study aimed to answer the following key questions. First one is how to machine learning improve the spam email detection. Second one is which machine learning algorithm is the most effective for the spam classification. And third one is what are the key challenges in designing an efficient spam detection system. Methodology. First step is the data collection. The two spam emails, the data were used. Each data set contain features such as words, keyword, words, frequency, special character uses, and capital letters. Second step is the data processing. Pre-processing. The dataset were cleaned and prepared. The feature extraction included headers, body contents, and metadata of emails. Third step is model training and testing. Data split 70% training and 30% testing. Cross validation 10-fold validation to improve the reliability. Comparison of multiple machine learning model. The fourth step is a performance evaluation. The model were evaluated based on accuracy, precision, recall, and F1 score and AUC.
Let's see the algorithms used in this research paper. First is gradient boosting, which is a powerful ensemble technique that builds the multiple decision trees sequentially to reduce the error. It has given us 98.6% accuracy. Here, gradient boosting, in the gradient boosting algorithm, what happens is the next generated tree can correct the mistakes made by the previous generated tree. So it will give us highest accuracy. Next is random forest, which is another example model that uses some multiple decision trees, and this has scored 98.3% accuracy. Next algorithm is neural networks. Basically, neural networks mimics the human brain function to identify spam patterns. It performed well with 98.2% accuracy. Next is naive Bayes, which is the probabilistic classifier, which is based on Bayes theorem that showed the moderate performance, which is 92.5% accuracy. Also, in terms of another parameter like 96% AUC, which means 96% area under the curve. Then decision tree, which is a simple model that splits the data into the branches for classification. It is less effective than the assembled models, which has given us moderate performance. Here, each algorithm has its strength and weaknesses, but goal is to find the one which is consistently perform the best. Here, let's see another example algorithms that we have used. So we will decide the best algorithm. Next is logistic regression. It is a statistical method for binary classification. It performed decently but not good as the gradient boosting algorithm. Gradient boosting is the best algorithm than the logistic regression. But what happens in logistic regression? It will predict the values for each by using the probability, and we will set some threshold, and based on that threshold we will decide or predict the output. It has given the good performance. Next is k nearest neighbor. which classifies the emails based on the similarity to the neighboring points. It performed poorly as KNN is a clustering type of algorithm. It is not good as other algorithms for detecting spam emails. Next is support vector machine, which is a margin based classifier. It among all these algorithms, it has given the worst performance, which is 60%. Next is AdaBoost. It is an adaptive boosting method, combining weak classifiers to the build the strong model. Performance, it performed well, but it has given 94.1% accuracy. Our key finding in this analyzing algorithm is that we have found the best algorithm, which is the gradient boosting algorithm, which has given 98.6% accuracy. So we have learned that gradient boosting is the best algorithm for spam detection due to it has the ability to learn the complex patterns, and random forest also performed well, showing assembled methods are effective. But support vector machine is ineffective because it struggles with complex textual data. So we learned that in modern spam detection should focus on using the assembled learning models rather than traditional classification methods. Next, we will see the evaluation matrix used. First is accuracy, which measures the percentage of correct classifications, which means how often the model's predictions are correct. Next is precision, which determines how many classified spam emails were actually spam. Next is recall, which measures how many actual spam emails were correctly identified. Next is F1 score, which balances the precision and recall for better spam detection. F1 score is the balance between precision and recall, ensuring neither one is ignored. Next is AUC, that is area under the curve, which measures how well the models differentiate between the spam and not spam emails. A well-performing model should score high across all these metrics. It will not just good in one of these. So let's see it in more detail. Accuracy. Accuracy measures the overall correctness of the model's predictions. It can be calculated by using the formula accuracy equal to true positive plus true negative divided by true positive plus false positive plus true negative plus false negative. Here, what is accuracy? Accuracy is the most important and essential evaluation metrics for machine learning. It tells us how often the model correctly predicts the spam and not spam. Here in this paper, we have studied that gradient boosting has achieved highest accuracy, which is 98.6%, which means that almost all the time it has correctly classified the spam emails. But also the random forest is also given 98.4% accuracy. But in the case of support vector machine, it has the lowest accuracy, which means it is ineffective in spam detection. But accuracy alone cannot decide the performance metrics of the model. Like we will take an example. We have the data set which 90% are good emails, means legit emails, and 10% are spam. But in this case, model will classify everything as a good email or legit email and still get 90% of accuracy, but it would completely fail in detecting spam. So accuracy alone cannot decide the performance metrics. Now let's talk about harmonic mean, which plays an important role in combining precision and recall. The harmonic mean is different from the regular average because it penalizes the extreme values more. The F1 score helps us to find the balance between the two. The harmonic mean of the precision and recall gives more weight to lower values, meaning a model must perform well in both areas to get high F1 score. If a model has a high precision but low recall, it means that it detects the spam emails accurately but misses some spam emails. If the model has a high recall but low precision, it means that it captures all the spam emails but also incorrectly marks some good or legit emails as spam. A balanced F1 score ensures the model isn't biased towards one metric. F beta score. F beta score is generalized version of the F1 score, where the beta decides or controls the balance between precision and recall. If beta is greater than 1, then recall is weighted more than precision, which means which it will catch the more spam emails, even if we get more false positives. Next is beta is less than 1. In this case, precision is weighted more than recall because more than recall, like reducing the false alarm even if we miss some spam. Next is beta equal to 1. It is a standard F1 score where it will give both the precision and recall equal weight. like balance the both precision and recall equally. This flexibility makes the F-beta score more powerful tool for tuning the model. The F-beta score can be calculated by using the formula F-beta equal to 1 plus beta square into precision into recall divided by beta square into precision plus recall. How F-beta is used in this paper? So in this paper, they have adjusted the beta to evaluate different spam detection needs. First, if missing spam is more harmful, like some spam emails contain cybersecurity threats. In that case, to catch more spam, even with false positives, they have used beta is greater than 1. But in the case where business emails are flagged as spam, like if false alarms are costly, in that case, to avoid the misclassification of some important emails, they have used beta is less than 1.
The next point is the data set. What data set were used? The research is used to publicly available data sets for training and testing. The feature set is included frequency, word frequency, the count how often the specific word, for example, free, money, credit, appears in an email, and character frequency, measure how often symbols like exclamatory symbol or a hash appear the common in spam emails. The capital letter uses the spam emails often contain excessive uppercase text. Metadata analysis analyze the email headers, sender information, and IP address. Data processing the 70% of data for training and 30% of the testing. 10 fold cross validation used to prevent overfitting. Result, here are three columns is matrix, accuracy, and AUC score. For a gradient boosting, the accuracy score is 98.6% and the AUC score is 0.985, and random forest 98.3 percent accuracy and 0.983 AUC score. The neural networks, the 92.5% accuracy and 0.982 AUC score. New bytes accuracy is 92.5% and AUC score is 0.960, and KNN 81% accuracy and 0.873 is a AUC score, and support vector machine, the accuracy is a 60.6 and AUC score is a 0.689. The strength of the approach: first one is a high accuracy result. The model achieve an impressive 98.6% accuracy, proving its a practical effectiveness, and use of cross validation. The 10 fold cross validation technique ensure that results are reliable and generalizable. Third one is a realistic feature engineering. The author carefully selected the spam indicators and improving the model robustness and multiple performance metrics. The study didn't just relies on accuracy, precision, recall, and F1 score and MCC, making it a result more meaningful. Limitations: the computational complexity. The technology requires the significant computational power, which can make it inefficient for large scale application or real time processing. Second one is the data dependency. The performance of the model heavily depends on quality and quantity of the data. Limited or biased data set can lead the inaccurate result. Generalization issues: the model may struggle to generalize well to unseen data, especially if trained on narrow data set. Fourth one is interpretability. The technology may function as a black box, making it difficult to interpret how the decisions are made, and which limits trust and usability in critical application. And the last one is the scalability. Some aspects of the technology may not scale effective to large data set and more.
Conclusion: the research proves that the machine learning, especially gradient boosting, is highly effective for spam detection. Resembled models like random forest and gradient boosting outperformed the traditional classifiers by capturing the more complex patterns. Future work should be focused on deep learning for better accuracy and real-time development for practical scalability. So we have concluded that gradient boosting can revolutionize the spam detection. Unlike traditional filters, the ML models can adapt and learn more patterns, more complex patterns over the time. Also, deep learning models such as neural networks could be explored further for more understanding the more complex patterns to improve the spam detection. Before wrap up, let's see some references that we have used to review this research paper. This includes some academic papers and articles that contributed to the study of spam detection using machine learning. The first one is the research paper that we have reviewed, the spam ML and efficient framework for detecting spam emails using machine learning. And next one is the article on the website that we have used to understand how F beta for model evaluation works.